So as we go to tonight's lesson, I want to focus on just some theory that came up a little bit in the last lesson, but also we have to be aware of as we come to today. So it looks like a bit of a mouthful on the screen, but let's have a quick look. So this over here is what we call reduction formula. And reduction formula help us reduce things like the sine of 150, which is in quadrant number 2. So if I had to visualize that, we're in quadrant number 2, and we use something called the cost diagram to help us. So the sine of 150, because it's in quadrant 2, will be positive, and we can rewrite that as sine of 180 minus 30. We say that's writing it in terms of nearest horizontal axis, which is 180. And then that can be reduced further to positive sine 30, where we only focus on the distance to the nearest horizontal. Give me a thumbs up if you are okay with the sine of 150 being the same as positive sine 30. Give me a thumbs down if you're like, what are you talking about, strange man? Okay. Because that's an important foundational idea that I'm going to use today. And if I said to you, I want you to reduce the sine of 210 to an acute angle, what would you get if you reduce the sine of 210 to an acute angle? Who feels like they know what the sine of 210 would be? If I visually look at 210, the angle 210 would get me all the way into this quadrant. And now the question is, what is that going to become? Answer in the chat. So it's definitely going to be the sine of 180 plus 30. But because sine is negative in that quadrant, right? This becomes minus the sine of 30. Okay, so this is what we call reducing an angle off the horizontal. And it's an important idea that's going to come up a couple of times today. Okay, so that is that bit there. So I'm going to take that away. So that's good. We can put a tick. Now, all of these things at the top, this is just the reduction formula for the second quadrant. This is the reduction formula for the third quadrant. That's for the fourth, and that's for the first. And that is the one where it says negative theta. Negative theta just means going in that direction. So in some ways, this is another way of looking at the fourth quadrant. This was the first quadrant. Fourth, third, second. Because if you look at these angles, that puts you in quadrant 2, that puts you in quadrant 3, quadrant 4, and that goes the whole way around and it gets back into quadrant 1. And then this one over here will be quadrant 4. Okay, now that is the reduction formula using the vertical. Sometimes we need to use something called a co-ratio, which is over here. And the reduction formula for co-ratios, if I said to you, you need to reduce the sine of 110 to an acute angle using the vertical axis. What is the nearest vertical axis to 110? Who can tell me what's the nearest vertical axis to 110? I can even draw a little drawing if I have to. Where would a 110 angle be? I guess it would be 90 and then a little bit past. So the nearest vertical axis would be the 90. And so we can rewrite this as the sine of 90 plus 20. Okay, now we ask ourselves, if we look a cast diagram, which tells us where trig ratios are positive or negative, is sine going to be positive or negative in that quadrant? Is sine going to be positive or negative in that quadrant? Okay, because it's in quadrant 2, it's going to be positive. But now here's the catch. When we reduce something off the vertical, we have to use the co-ratio of sine. What is the co-ratio of sine? Who can tell me what the co-ratio of sine is? Yes, it's going to be cos, and it's going to be the cos of 20. Now, this is quite a different type of formula because instead of using the nearest horizontal, you use the nearest vertical. And when you do the reduction, you notice that you go from a sine to a cos. So this is quite an important idea. And so I'm going to do one more after this using this idea. Give me a thumbs up if you followed the co-ratio reduction though. Give me a thumbs down if you didn't follow it. Okay. So now what I want to talk about is if I have the sine, in fact, what I had sine last time. Okay. Oh, there's a couple of downs. Okay, don't worry. We're going to do another one here. If I say you need to reduce the cos of 250 using the nearest vertical axis, I want you to think about that. So let's visualize what an angle of 250 looks like. 250 would be 90, 180, and it basically gets to here. What is going to be the nearest vertical axis to 250? What's going to be the nearest vertical axis for 250? But remember, I'm asking for the vertical axis because we're using, instead of using, we're specifically focusing on using functions. And so it's going to be 270. If I was using horizontal axes, it would be 180. But because I've specifically said I want to do this, okay, now what I'm now going to do, I'm going to rewrite this using the nearest vertical axis. What do you think is going to go inside this bracket? What do you think is going to go inside this bracket? Remember, when we use, we have to go 270 minus 20 because we know we have to get back to this thing. Okay, now I want to ask you, is the cos of 250 positive or negative in this quadrant? Is the cos of 250 positive or negative in this quadrant? Okay, so it's going to be negative, but I don't write cos of 20 now because I'm using the vertical. What's the co-ratio of cos? What is the co-ratio of cos? It's going to be sine. And so we can reduce the cos of 250 is equivalent to minus sine 20. And we call that using co-functions or reducing off vertical axes. Now, when you're given a choice, you would normally use the horizontal one if you can, but sometimes you're forced to use vertical axes. And so it's important you have the skill set to do that. Give me a thumbs up now if you feel like you understand how to use the vertical axis. And thumbs down if you don't. So to run, the reason it's 270 minus 20 is you always use, when doing co-ratios, you use the vertical axis. So you always rewrite it in terms of the nearest vertical axis. You're going to get lots of practice on this tonight. So this was just the warm-up, the kind of getting you guys aware of the main ideas that are going to be happening. Now, there are two other identities, or there's some other things that we need to have in our toolkit for today. The one important one is that you can always rewrite the tan of theta as the sine of theta over the cos of theta. Okay, they call that the quotient identity. And then you can also rewrite two sets of sine squared theta plus cos squared theta equals 1. And that's called the square identity. And the square identity can actually be rewritten in two other ways, where if you move the cos to the other side, it becomes minus, or you move the sine to the other side, it becomes minus. And so these are identities that we have to be aware of. Now, at this stage, for those who are struggling with reduction formula, don't worry, that's going to be a large part of today's lesson. I'm going to come back to it in a moment, but I just want to test out your knowledge. Give me a thumbs up if you are aware of these identities here. Give me a thumbs down if you're not aware of these identities here. And Keisha and Lisakanya, I'll get back to you. I will show you in today's lesson how these work. Okay. And then the last thing that I'm not sure if we touched on in the last lesson, but there are these things called special triangles. And sometimes they will say to you, you have to evaluate something like the sine of 60, but you're not allowed to use your calculator. And what you need to do in that situation is have these special triangles. And if I look at a special triangle, the sine of 60, well, that would be O, that would be H, that would be A. So we could say the sine of 60 will just be, well, over H, so it's root 3 over 2. Now, using that idea, can you tell me what the sine of 45 is without your calculator? Using these triangles on the left, and I want you to put the answer in the chat. I want you to apply the logic that you see. So sine is still OH, but the O will be a 1 and the H will be a root 2. So this is what we call using special triangles and evaluating an expression without a calculator. Okay, so that is our base ideas for today. Let's get crack-a-lacking with a proper type of question. So to start off today, you are going to try and simplify without a calculator a question that I am highlighting in yellow. And I'm going to give you 2 minutes to do that. See if you can simplify this without a calculator. And if there are questions, if you're uncertain, I want you to pop your hand up and we can have a little chat. I'm just dying to have a chat to a student. Otherwise, put your question in the chat and I will help you as I can. What I will say is this question boils down to 4 or 3 little reductions you need to do. Okay, over to you guys. And I'm going to also just get some water because my throat is feeling a bit sore. Okay, and Tukozo, you shouldn't be seeing faces of anybody else on the screen. Maybe, Kia, if you can just check that the setting is on to highlight just me as the teacher, that you shouldn't see anybody else's faces.
That's weird. I think currently you're the only one that is like on spotlight.
Okay, so that's fine. It was obviously like a random random thing. Cool. Okay, so how are we going to reduce 180 plus x? I guess we have to just visualize what it looks like. So that would be that. And then the cos of 330 for me would look like that. And the tan of 150, that should look like that. Now, I think using the horizontal will be the easiest way to do this. And in the first one, it's almost been done for you. So the sine of 180 plus x is already in terms of the nearest horizontal. But the next one, I would rewrite as that, because the nearest horizontal to 360, I mean to 330 is that. And then I would write the tan of 180 minus 30, and then the tan x at the bottom will stay the same. But we still have to do our reduction. And for me, the sine of 180 plus x is in quadrant 3, which means it must be negative. And then it will be negative sine x. Oh, is it sine x at the bottom? Oh, love it. I love the feedback. Thank you, everyone. I'm making a human error there. Okay, so minus sine x on the top. Then for this one, because I'm in quadrant 4, I'm going to get positive cos 30. And then I'm going to get negative tan 30. And then I'm going to get the sine of x. Zwantile, I just made that up. That was me just being a little too relaxed, I suspect. So I want to know, did everybody understand how I got from this step to this step? Thumbs up if you understood that jump. Thumbs down if you didn't follow there. Okay. Bianca, I would love a question. Same with Keisha. Where did I lose you? Tigavatso, let's go to you. Can we unmute Tigavatso? I see a hand
Good
went up.
afternoon, sir.
Hey, how can I help?
With cos 360 minus 30.
Yes.
Cos is positive on the fourth quadrant, right?
Yes.
So in the bracket, it's gonna be 360 minus 30. Then
Yes.
when we reduce it, it's gonna be sine in cos into negative 30. Don't we take the negative to the other side so that it can be negative cos 30?
Okay. Let me have a look at this. So if you think of cos 330, are you happy that I get to there, that I'm in quadrant number 4?
Yes, sir.
So I think this positive is fine. So if you think about that, it has to be positive. How far away is it from the nearest horizontal? Well, the nearest horizontal is 360. So you have here 30. So that's why it's positive to be in quadrant 4, and then you have 30 there. Does that make sense? I lost you there. Because it's in quadrant 4, it needs to be positive. Yeah. So what I want to suggest is that I am noticing there's a sine x on the top and a sine x on the bottom. And so I'm going to cancel out those two sine x. Pleasure, Tegamatsu. I'm glad that I could help. Now, if I then say what's left, there's also a negative times a negative, and a negative times a negative is a positive. So all I'm left with is the cos of 30 times tan of 30. Now, I'm still not done. Who thinks they have the next step for me? This is a good question. Who feels like they might have the next step for me? Change tan. Yes, so Morgan has suggested that I go back to the idea from earlier in the lesson, and I say, look, tan 30 can actually be written as the sine of 30 over the cos of 30. And so what I have is I have the cos of 30 times the sine of 30 over the tan, the cos of 30. And then a lovely trick that I like to do if I'm confused about fractions is I can always write something over 1, and then I see that this can cancel with this, and so all I'm left with is sine of 30. Okay, but now, how do I evaluate the sine of 30 without a calculator? What do I need to use? What do I need to use to evaluate without a calculator? Special triangles, yes. And so the special triangle that I need, and there's different ways of writing it, but the one is always opposite the 30. I'm going to say, well, that's going to be the O and that's going to be the H. And so O over H is going to be 1 over 2, which is a half. Let me just zoom back in just so that you can see the whole journey that we went on. Okay, now what I want is I'm going to leave that up on screen for a moment because I can see that definitely was working our brains hard there. But for those who feel comfortable, I would like you to try and move on to this question over here. Question number 2. See if you can do that one. And then if students are feeling a bit unsure about this question, I would love a question that we can talk more about it while other students are busy on the green one. We need to think about, so if cos is negative, do we go anti-clockwise? Yes. So I assume you're talking about this one, so no, I'm sorry, you're talking about this one. So if I wanted to visualize the cos of minus theta, I'm going to be in quadrant 4 now. Okay, for those students who, if you want to record the working out for the previous question, take a screenshot because I'm about to wipe it out. So I have more space. So actually, let me make it smaller because there's lots of them. So 750, well, that would be going once, going twice, and here 315 would be here. The cos of minus theta would be here. 360 minus theta would be here. Sine of 300 would also be here. And the sine of 180 minus theta would be here. So all I'm doing in these drawings is showing you what quadrant I'm in. So I've just done the top line. Give me a thumbs up if you follow how I did the top line of that question. I just want to see if I'm going to slow down or are there any questions about the top line? Okay, and I want you to do the bottom of the denominator as well, and then see if you can get the answer to this question, and then we'll take a break. How did we end up with 30? So Morgan, if you think about 750, the angle 750 is 2 loops around the sun plus an extra 30 degrees. So because trig functions are periodic, they repeat every 360. You'll notice that I didn't write 360 plus, I wrote 720. Those are multiples of 360. So, I mean, I could have also written 360 plus 360 plus 30, but, you know, it just takes longer. And remember, 360 is the nearest horizontal axis to 750. So, Yamkela, I hope that helps. Morgan, I hope that helps in seeing what's going on. So I'm going to get cos theta, and here I'm going to get minus sine 60, and here I'm going to get sine of theta. So now I want to see what is in common to both the top and the bottom. And I can definitely notice that there are 2 causes, so those are going to cancel out. Now, I've got a bit more tricky things to deal with. Who has a suggestion? Why is the 60 negative on sine? This is because that this is quadrant 4. So if you go to quadrant 4, sine is actually negative in quadrant 4. So only cos is positive in quadrant 4. And so that's why there needs to be a minus. And how did you get positive cos 0 from the cos minus theta? Okay, the cos minus theta is in quadrant 4, and all I said was it's the same as saying 0 minus theta. So 0 is a horizontal here, right? That's 0. So I just said 0 minus theta, and if I go into this quadrant, that is where the negative theta goes, and cos is positive. So that's why I had to have and how far away is it from the nearest horizontal? It's just theta away. So that's why I get positive cos theta. Yeah. Because in quadrant 4, and this angle is in quadrant 4, cos has to be positive. Okay. Now, I'm a bit stuck. Well, I'm not really stuck, but what is my next step going to be? What is my next step going to be here? I'm a bit, it's like I know I'm on the right track, but it feels like you could change tan. I could change tan, but the problem is I don't have any other angles that are 45. I feel like I would rather change something else. Is there a way I could change this to something else? What other tricks do you guys have up your sleeve for changing things here? If we look at if we think back in the lesson, what was the other technique? Didn't we use co-ratios? Oh, you could use special triangles. Yeah, we actually could. We could use special triangles, but I was just thinking maybe I could rewrite. So on the top, I've got the cos of 30 times minus tan 45. I was thinking I can rewrite that as the sine of 90 minus 60. Now, what does that allow me to do to that sine of 90 minus 30? Sorry, that was me making a boo-boo there. What does it allow me to reduce here? So I think that will become, yeah, so this will become minus cos 30. And on the top, if I move the minus to the front, I've got minus cos 30. And then all I've got left is also a tan of 45. But I can cancel those out. So now I have to just evaluate the tan of 45. And we just did that in the previous question where we saw, look, 1, 1, root 2. So this would be, well, I need to be careful. This is O and this is A. This is H. So this is O over A. So this is going to be 1. So the whole thing is going to be 1. Okay, did I go a bit fast there, Monswandile? Let me slow down a little bit. So the main thing that I did was I said, look, I can rewrite this as 9 minus 30, and then I can actually change this to the cos of 30. So if you think about, if you look across here, what happened to the sine? Okay, let me do this one again. Do you agree that if I have to visualize the angle of sine of 60, 60 would be here. How far away is it from the nearest vertical axis? It's just going to be 30 degrees away. So I rewrote the sine of 60, the sine of 90 minus 30. Okay. Now, oh, did I leave something out? Sorry, I did. I left out the sine of 180 minus theta. So let me just quickly put that back in, and then we'll go from there. So I have the sine of theta, which is still sitting there by itself. And so let me just redo that last bit. So I converted this to minus cos 30, and that was cos 30. And then this was minus tan 45. And on the bottom here, I still have my sine theta. So I cancel out the cos 30, I cancel out the minus, and now I am left with the tan of 45 over the sine of theta. And that's what I left out. Now, if you look at the special triangle, I'm going to get 1 for tan of 45, and then all that's going to be left is 1 over the sine of theta. Okay. So, everyone, if you are confused about this, I do want you to go back and look at the recording. And I know that there was some tricky stuff going on there, but at the same time, I think it's important we take a break now, because otherwise we're going to overwhelm our brains. And so can we have everyone's cameras on, and can we stand up? It's just going to be a very quick break today because I think that we used up quite a bit of time. Let's just stand up and do some nice deep breaths. I'll answer the questions that are coming through after the break. Let's do 2 more. One more. Okay, shake out some arms. Shake out some legs. And all I'm going to ask you to do is I'm going to ask every single person, you need to get your blood pumping. So I want you to clear some space wherever you are. I'm just going to do 20 jumping jacks. Okay, start in 3, 2, 1. Let's go. 1, 2, 3, 4, 5, 6, 8, 9, 10. Halfway. 2, 6, 7, 8. Ooh, and there it is. Okay, so I hope that your body is feeling like it's had a bit of a break. And just to address the questions from before the break, where does the 45 come from? So if you think about the 1, how does it suddenly become a 1? I go to the special triangle here and I say, well, tan is the same as O over A. the sine of 30 is still, sorry, the sine of theta is still there. And if you think about what's on this, what's over A, it's just 1 over 1. Oh, I can feel my heart rate. Now, you don't have to do so many steps, but I'm just trying to make it very clear. Okay. Orokanisa, what is your question? Can we unmute Orokanisa?
Good afternoon, sir.
Hi, how can I help?
Sir, I wanted to ask, why isn't it that we can't write this, the very first step there? Why can't we write cos is bracket 360 minus plus 390 because it gives us 750?
Say that again. So how do we?
Why can we not write that 360 plus 390 in brackets?
Oh, you can write that. That's fine. It would be the same thing. It would be
Oh.
equivalent. Yeah, no problem.
Okay.
All right. Let us do another one. It feels like we're starting to get this. Should we do one more? Let's do one more like this. In fact, let me clear some space because I think it's a bit cluttered. So take a screenshot if you want. And we're just going to do one more like this. Just, can we mute? Yeah, thanks. So we're going to do number 3. So for those who can already see number 3, we're going to try and do number 3. I will zoom in a moment, but I just want to clear my board. So let's see if you can do that. Number 3. And that's got a bit big. And other stuff I'll move out the way in a moment. So we are doing number 3. See if you can reduce that. Okay, I can remove the pink color, no problem. I'll make it yellow instead. I think yellow is a bit more transparent. Okay, let's do it. No, it's 480. Actually, 480 gets even further. 480 goes all the way to here. So now what is that going to be? So 0. There's a couple of different ways you can do the tan of 480. I don't know which way most students are going. I was going to write it as 540 minus 60, but you don't have to do it like that. You can also use the nearest vertical. So you couldn't write 360 minus 120. You could write the tan of 360 plus 120, but then you're going to have to reduce that even further to the tan of 120, and then the tan of 120 is going to be reduced even further. So that would become minus tan 60. So there's two ways in the end, we're going to get down to minus tan 60. There's different ways to get there, but I'm just using 540 as the nearest horizontal. And then this would be, you could use that, Keisha, but remember 450 is a vertical axis. And so you're going to have to change from, you would have to use a co-ratio, and co-ratios of tan are not really in the syllabus. Like if you look at how I wrote 450 as a vertical axis, if you were using 450, you're using the nearest vertical axis. Okay, so cool, pleasure. So what do we got here? We got 360 minus 60. Then cos 14, I can't do much about that. And then sine of minus 135. Okay, it's a couple of different ways we could do that. What would be the nearest horizontal? I suppose it would be minus 180. So you don't have to do it like this, but for me, following the logic of what I've done so far today, it would just be minus 180 plus 45. Because the nearest horizontal is minus 180. So I'll give a bit more time for the bottom line, but let me know if you have questions about the top line here. Morgan says 480 minus 60. You can't do that, Morgan, because you need to tan 480 minus 60. You would get to 420. So it's all about establishing where the nearest horizontal axis line is. So for this one, if you think about it, you go 0, 90, 180, 270, 360, 450, 540. And so the angle you're interested in, your 480 is sitting in this quadrant, which is closest to that horizontal axis. So Andile, why minus 180? Because the angle you were given is minus 135. So if you imagine, where does minus 135 go to? So here's minus 90, here's minus 135. Now, your angles, your horizontal axes can go the other way around. So this would be minus 90 and this would be minus 180. And if you ask yourself, how far away is it? It's going to be 45 degrees away if this angle is. So if I write minus 180 plus 45, I still have my minus 135. Now, okay, so what we're going to say here, sine 90 plus 24. And then here, I'm going to say cos 180 plus 45. Now, I have used a vertical axis here. I didn't have to. I could have said something different, but I'm just kind of trying it on. So let's go to the next one. So this is going to be minus tan 60. This is going to be minus sine 60. This is going to stay because, oh, this should be 14. This should be 14, not 24. So that was my boo-boo there. This should be minus the sine of 45. Thanks, Nkosi. I see you picked that up before I did. And here, it is going to be positive cos 14. Oh, I've left something out here. Let me. So cos 14, and then this was going to be minus sine 45. Positive cos 14, and then this is quadrant 3, which means I've got to have minus cos 45. Okay, Keisha, which 180 are you talking about? Are you talking about the 180 next to cos? Are you talking about next to the sine? Which one are you talking about? Next to the sine. Okay. Whenever you reduce something, you always ask yourself, what is the nearest horizontal axis? And if you think about minus 135, this visual gives you that. But the nearest horizontal axis will be minus 180. And so you go minus 180 plus 45 to give you the angle minus 135. Have a look at that on the recording. It'll make more sense. I did describe it a bit earlier, but I know it's a bit sneaky because I'm using a negative angle. Okay, what am I going to do next? What's my next step? What's going to be my next step? So what turned the sine to cos is that I used the vertical axis. And the vertical axis includes 90 to 70, these types of things, right? So I really want you, Morgan, to focus on the fact that I wrote this in terms of a vertical axis, and this is in quadrant 2, and sine is positive in quadrant 2. And so that's why I switched to that. So now I'm going to cancel out that and that. Okay, now I'm also going to cancel out 2 of these negatives because there's a negative times a negative is a positive. So all I'm left with is the tan of 60 times the sine of 60. Oh, you know what? There's a negative on the bottom and a negative on the top. So this can also cancel out. All my negatives are gone, thank goodness. And what have I got left? I've got tan 60, sine 60. I've got a sine of 45. And then on the bottom, I've got a cos of 45. Notice how all the negatives knocked each other out. What's the next step? What do you think I need to do? We spoke about it in the previous question. I think we can change this into something different. So special triangles, and you could just go straight special triangles now if you like. But what I was thinking is we can write that. Oh, actually, that's not really going to help us. Say sine of 60. Yeah, I would just go straight to your special triangles. You're quite right. So if I was doing special triangles, I need 2 of the triangle on the side. So I'm going to go 45, 45, root 2, 1, 1. And here, I'm going to have root 3, and this is going to be 1. So I need to substitute value.
Sorry, sir.
Yeah.
How about we change cos 45 to sine 45? Then they're gonna cancel each other out.
Ah, that is such a good idea. I didn't spot that. Can everybody see that? We can change the cos of 45 using the sine of 45.
Function. It's sine. Yes, it's gonna be sine 90 minus cos 90 minus 45. Then it's gonna change to sine 45.
Perfect. That was such a good spot. Well done.
Thank you.
And that makes life much easier because now I can just write this like this. And so we go, the tan of 60 is going to be O over A for that triangle. And the sine of 60 is going to be O over H. And what do we have for O? We've got root 3 over 1 times root 3 over 2, which is going to give us 3 over 2. And ladies and gentlemen, I think that is a good place to end for today. We have done some serious reduction formula and simplification questions, but I can almost guarantee you there's going to be 10 marks of this in your exam. In fact, I can guarantee you. And so if you go over this and you do the quizzes and stuff like that, then you will have had a strong step in the right direction to mastery.